Hello, and welcome to Sleepy Stories Space. You found your way to a quiet corner of the internet, a place where the universe opens not with noise or urgency, but with stillness and wonder. Here we drift through the stars, the planets, and the mysteries beyond. We explore discoveries, questions, and the quiet beauty of the cosmos that stretches above us. Thank you for being here. If you find comfort in these journeys, I invite you to like this video. And if you'd like to return to more quiet explorations of the night sky, you can subscribe. Each story is an invitation to rest, to reflect, and to find serenity beneath the endless expanse of space. Tonight we begin a gentle journey into one of the most profound ideas ever imagined, a theory that changes how we understand the universe itself, and how every planet, every star, and even the light that glimmers across the night sky moves and bends in ways that are almost impossible to see. It is a story about gravity, time, space, and the subtle, invisible ways the cosmos shapes itself. It is the story of general relativity. Imagine, for a moment, lying beneath a clear night sky, watching countless points of light flicker softly in the darkness. Some of these lights are nearby stars, familiar and warm, while others are distant galaxies, so far away their glow has traveled millions of years to reach you. The universe is vast, and yet in this quiet moment you feel a calm connection to it. You are a part of the same fabric of existence that stretches across every corner of space, touched by the gentle pull of gravity and cradled by the curvature of space-time itself. 100 years ago, a man named Albert Einstein had a vision of this hidden geometry. He saw the world not as a stage where objects are pulled by invisible forces, as Newton had described for centuries, but as a woven fabric where matter shapes space and space guides matter. Every planet in orbit, every falling apple, every beam of starlight is part of this quiet conversation between mass and the shape of the cosmos. Einstein's insight was gentle yet revolutionary, a whisper that changed how we understand the universe forever. General Relativity, completed in 1915, tells us that gravity is not a force pulling objects together, but the effect of curved space-time guiding their paths. Mass bends space. Space tells matter how to move. Time, too, flows differently depending on the depth of gravity, slowing near massive bodies and moving more freely far away. These ideas, once only imagined in thought experiments, are now measured with exquisite precision, from atomic clocks on Earth to satellites orbiting high above. As you settle in, allow yourself to drift with the ideas, to float along the invisible curves and bends of the universe, from the motion of Mercury around the Sun, which puzzled scientists for decades, to light bending around distant stars during eclipses. Each observation quietly confirmed Einstein's vision. The cosmos is not rigid and unchanging. It is a gentle, dynamic fabric, responsive to everything within it. Tonight, we will explore this fabric together, not as a lesson rushed or filled with noise, but as a soft meditation on the quiet elegance of space-time. From the slow, measured pull of gravity to the stretching of the universe itself, from the dance of planets to the bending of light, we will trace the contours of reality and the subtle ways it shapes all that we see. And as you listen, you may find your own thoughts slowing, your mind drifting softly like a satellite orbiting in the calm reaches of space, where every question, every discovery is a gentle invitation to wonder, to rest, and to imagine. So tonight, we begin this story. The story of a quiet question, a thoughtful mind, and a universe that listens. We will explore the ways space-time curves, bends, and hums with invisible motion. And as you drift through this journey, may you feel the calm, the peace, and the quiet beauty of a cosmos that is always there, waiting to cradle every thought and every dream beneath its endless expanse. Let's begin with the story of how a quiet question about falling, led to a revolution in how we see the cosmos. Albert Einstein was born in 1879 in Ulm, Germany, in a world lit by gas lamps and shadowed by centuries of Newtonian thought. Even as a child, he moved through this world with quiet attentiveness, noticing the way light glimmered on polished surfaces, how shadows stretched and bent across the walls of his home, and how the simple motion of objects seemed to follow patterns he could sense before he could explain them. He observed the slow drift of clouds across the sky, the way a spinning top resisted its fall, and the almost imperceptible shimmer of reflections in water. And, as you listen, allow your awareness to trace these patterns softly within your mind, letting your chest rise and fall gently with the rhythm of the universe, as if you too are spinning slowly, weightless, in a vast silent sky, the faint hum of your own breathing echoing the quiet pulses of the cosmos. By his teenage years, Einstein's curiosity had taken a deeper turn. While his peers recited lessons and solved arithmetic problems mechanically, he explored the motion of light and the nature of time, as though both were soft threads he could follow with his mind. The principle of relativity, first glimpsed in Galileo's observations centuries earlier, guided his thinking. The laws of physics remain consistent no matter one's motion. But Einstein extended this principle further, sensing a universe that behaved consistently not only for moving objects, but for light, energy, and the unseen weave of space itself. And as you consider this, feel your body relax with the gentle constancy of the cosmos, the invisible threads of space holding you securely as your mind drifts along these silent currents of thought, each breath expanding and contracting like a soft wave of calm across a starlit ocean. In 1905, while working in the Swiss Patent Office, Einstein published papers that would forever change physics. The special theory of relativity revealed that space and time were not separate, absolute entities, but intertwined in a flexible continuum. The famous equation E=mq showed that mass and energy are two forms of the same essence. Special relativity explained that motion is relative to the observer, and that nothing, not even light, escapes this interwoven fabric. And as you listen, you might feel your own perception of time stretch softly, your awareness flowing slower and deeper with each breath, like a beam of starlight gliding over a silent, vast night sky. The quiet darkness enfolding your thoughts as they drift along its infinite expanse. Special relativity explained motion at constant speeds, yet it left a question lingering. What of gravity? Newton's law described it as an invisible force pulling at a distance. Yet certain celestial phenomena, such as the slight wobble in Mercury's orbit, remained elusive. Einstein's mind, attuned to these subtleties, began to see gravity differently. Not as a pull, but as a gentle curvature in the fabric of space itself. And as you reflect on this, feel the invisible curves around you holding you softly, the gentle pull of Earth cradling your body while your mind drifts freely among quiet, invisible arches of space-time, each thought floating without resistance, like a slow, drifting cloud in a calm twilight sky. The turning point came with the equivalence. Principle, a quiet, elegant insight. Standing on the surface of the Earth feels the same as accelerating upward in a windowless elevator, and floating in free fall feels weightless. From this, Einstein realized that gravity and acceleration are two faces of the same reality, a revelation that would allow him to see the invisible curves of space-time. As you hear this, notice the soft rhythm of your own heartbeat, the ease of your lungs expanding and contracting, as though your body too is floating in a gentle orbit, responding to forces it does not need to resist. And let your awareness drift slowly along these invisible curves, calm and steady as the distant stars twinkle silently overhead. Einstein's work relied on both thought experiments and rigorous mathematics. He studied Bernhard Riemann's 19th century ideas on curved surfaces, which allowed him to describe how space itself might bend and ripple around mass. Each equation he wrote was a quiet mapping of reality, a careful tracing of the invisible geometry that surrounds us. And as you follow this, picture yourself tracing lines of starlight across the night sky. Your awareness drifting along these subtle curves, your body completely supported, your mind soft and receptive to the serene truths of the cosmos, each breath a gentle rhythm aligning with the silent expansion of the universe. The path to general relativity, completed in 1915, was long and deliberate. Einstein wrestled with complex equations, exploring dead ends and contradictions. His persistence was steady and patient, like a river carving its way through stone over centuries. And as you contemplate this dedication, allow your own thoughts to drift slowly like water, the surface of your mind reflecting the stars above, smooth and undisturbed, carrying gentle currents of wonder and serenity, the weight of your body held securely while your mind floats through the quiet night. One of Einstein's bold predictions was that massive objects could bend the path of light. He calculated that starlight passing near the sun would curve, a phenomenon later confirmed during the 1919 solar eclipse by Arthur Eddington and his team. They observed stars slightly displaced from their usual positions, the universe itself whispering the truth of Einstein's vision. And as you hear this, let your awareness move with the light, soft and curved, tracing gentle arcs across the silent, dark canvas of the cosmos, your mind settling into the elegance of these invisible flows, your body completely at ease and aligned with the soft pull of the universe around you. Time itself, Einstein proposed, moves differently depending on gravity. Clocks closer to massive objects tick more slowly than those far away. This gravitational time dilation is measurable with atomic clocks and corrected for in GPS satellites today. And as you consider this, notice the slow, unhurried passing of time within your own body. Each heartbeat and breath aligned with the gentle curvature of space, flowing deliberately and calmly onward, the rhythm of your chest echoing the quiet patterns of the cosmos. Even before it could be tested, Einstein's theory suggested consequences that would challenge imagination for decades. It foretold black holes, points of infinite curvature where space and time fold upon themselves. It also predicted gravitational waves, ripples across the cosmic fabric caused by accelerating masses. These waves were directly detected a century later by LIGO in 2015, confirming yet another whisper of Einstein's foresight. And as you feel this, allow your awareness to ripple like these waves, soft and slow, carrying the quiet majesty of the universe through your mind and body alike, the energy of the cosmos moving with each subtle pulse of your chest. Einstein relied on mental images to understand the unobservable. He pictured elevators, falling objects, beams of light, all guides to intuition. His genius lay in merging imagination, observation, and mathematics. Each equation was not only a tool but a map of reality, tracing how planets, light, and stars move along invisible contours of space-time. And as you listen, feel your body settle deeper, the surface beneath supporting every thought, allowing your mind to drift gently along these invisible contours, serene and at ease, your awareness moving in harmony with the gentle curvature of the universe. By 1915, the theory of general relativity was complete, transforming our understanding of the universe. Gravity was no longer merely a force, it was a manifestation of geometry, a rhythm in the silent fabric that carries everything. From the motion of planets to the bending of light, from subtle time dilation to the profound mysteries of black holes, Einstein's vision opened a new world, and as you consider this, let your awareness follow these rhythms, slow and steady, feeling your mind and body move in sync with the calm, ordered beauty of spacetime itself, floating effortlessly in the infinite expanse of the cosmos, your thoughts serene and unhurried, each breath a quiet echo of the vast, intricate universe that surrounds and enfolds you completely. Einstein's work also revealed that massive objects do not just curve space, they shape time itself. The deeper the gravity, the slower time moves relative to regions of weaker gravity. This insight informs not only astronomy, but modern technology, ensuring GPS satellites remain synchronized with Earth's surface. As you hear this, allow yourself to feel a gentle slowing, your mind and body softening into the comfort of this cosmic rhythm, sensing each second stretching slightly, each breath a tender reflection of the universe's patience and balance. The precision of Einstein's mind was matched by his quiet persistence. He revisited assumptions, challenged his own thinking, and carefully explored the implications of each idea. By integrating mathematics with conceptual experiments, he could visualize phenomena that no human eye had seen. Let your awareness follow the path of this quiet curiosity, feeling the careful unfolding of ideas like a delicate constellation revealing itself in the night, each star a soft point of understanding, guiding you calmly through a sky of knowledge. Even today, the predictions of general relativity continue to be verified. Gravitational lensing shows distant galaxies stretched and bent by intervening mass, and orbiting clocks measure time differently at varying altitudes. Consider your body gently resting, each inhalation and exhalation aligning with these subtle cosmic shifts, the sensation of floating within a universe whose silent order mirrors the steady rhythm of your own being. After the publication of the special theory of relativity in 1905, Einstein began to consider a deeper question. What about gravity? While special relativity described the behavior of objects moving at constant speed and the intimate connection between space and time, it left gravity untouched. Newton had long described gravity as an invisible force pulling at a distance, explaining planetary motions and earthly falls alike. Yet certain observations, like Mercury's anomalous orbit, remained unresolved. Einstein, reflecting on these subtleties, began to see gravity not as a force acting across empty space, but as a property of the geometry of space and time itself. As you hear this, allow your awareness to move gently with the idea, imagining the silent, invisible curves of space-time wrapping around you, your body resting lightly in their steady embrace. Each breath flowing slowly along the contours of a universe unseen yet profoundly present. Einstein's journey toward general relativity was guided by thought experiments, mental exercises that allowed him to explore the unobservable. One of his most famous was chasing a beam of light. He imagined traveling alongside a ray of light, moving at the same speed, observing whether the light would appear stationary. Classical physics could not accommodate such an experience. A stationary light wave was impossible under Maxwell's equations. This thought experiment, gentle yet profound, nudged Einstein toward the idea that space and time are not rigid and separate, but flexible, intertwined, and relative to the observer. As you reflect on this, let your mind drift alongside this ray of light, gliding silently through a calm, dark expanse, feeling your body weightless and your thoughts slow, stretched across the quiet fabric of possibility. During the next decade, Einstein combined these insights with rigorous mathematics, drawing on the differential geometry of Bernhard Riemann and others. This branch of mathematics, developed in the 19th century, provided tools for describing curved surfaces, allowing Einstein to model the bending of spacetime around massive objects. Each equation, each symbol, was a precise tracing of invisible structures, a map of reality beyond ordinary perception. Feel your attention following these invisible curves, flowing gently through your body as though each breath traces the subtle warping of space itself, your mind soft, receptive, and entirely supported by the unseen scaffolding of the cosmos. The equivalence principle became Einstein's guiding light. It states that locally within a small region, An observer in free fall experiences no gravitational forces, feeling indistinguishable from being in inertial motion without gravity. In other words, falling inside a windowless elevator or floating freely in space produces the same sensations. From this principle, Einstein understood that gravity is not a force acting across space, but a geometric feature of spacetime itself, bending paths of matter and light. Let your awareness rest in this quiet insight, feeling the subtle pull of Earth beneath you, your body cradled as if floating along gentle curves, fully supported by a universe that bends around and through you with infinite patience. Einstein also explored the implications of these ideas through other thought experiments. He imagined clocks at different heights on Earth, measuring time differently under varying gravitational potentials. He pictured light beams bending as they passed near massive stars, and the tidal stretching of objects falling toward dense bodies. Each scenario illuminated how gravity is geometry, how space and time respond to the presence of matter, and how observers perceive motion relative to the curvature of their surroundings. As you consider this, picture your awareness drifting slowly along these invisible paths, your body relaxed, each inhale soft, each exhale releasing tension, aligned with the gentle, imperceptible curvature around you. By 1915, Einstein completed his theory of general relativity, expressing it in a set of equations describing how matter tells spacetime. How to curve. And curved spacetime tells matter how to move. These equations replaced Newton's force-based description with a geometric model. Planets orbit stars, not because they are pulled by invisible forces, but because they follow the natural curves in spacetime shaped by massive bodies. Allow your attention to flow along these curves, your mind and body drifting like a spacecraft guided by invisible rails, gliding slowly, effortlessly through a calm cosmic sea. One of the immediate predictions of general relativity was the bending of light by gravity, later confirmed during the 1919 solar eclipse. Stars near the sun's edge appeared slightly displaced, revealing the subtle warping of space itself. This moment was not only a triumph of observation, but a poetic confirmation of Einstein's intuition that geometry governs the universe of the largest scales. Feel your awareness. Follow these arcs of light, tracing soft, silent paths over a dark sky, your breath moving gently in harmony with these subtle curvatures, your mind calm and expansive. Gravitational time dilation, another consequence of general relativity, describes how time itself flows at different rates depending on gravitational potential. Clocks near massive objects tick more slowly than those further away. This phenomenon is not abstract. It is measured and corrected for in modern technologies like GPS satellites. As you consider this, feel the rhythm of your own heartbeat aligning with the quiet flow of time, each second lengthening and softening, your awareness carried forward gently, fully present in the vast, patient cosmos. General relativity also predicted that massive bodies can generate ripples in space-time gravitational waves, caused by accelerating masses such as orbiting neutron stars or merging black holes. These waves, directly detected a century later by LIGO in 2015, confirmed yet another aspect of Einstein's profound vision. Let your mind drift along these gentle ripples, each pulse moving softly through your awareness, carrying the quiet resonance of a universe vast beyond comprehension. Each breath a reflection of the slow, deliberate undulations of space-time itself. Einstein's approach combined creative thought with precise calculation. He visualized scenarios, questioned assumptions, and rigorously tested consequences mathematically. This interplay of imagination and discipline allowed him to conceive phenomena no human eye had yet witnessed. Bending light, warped time, orbiting bodies following curved geodesics. Allow your body to mirror this rhythm, inhaling with curiosity, exhaling into calm acceptance, feeling your mind stretch gracefully along the curves of reality he revealed, relaxed and attuned to the quiet elegance of these cosmic truths. The differential geometry underlying general relativity describes a spacetime that is dynamic, flexible, and responsive. Matter influences curvature. Curvature guides motion. This feedback loop governs everything from planetary orbits to the trajectories of light near massive stars. As you breathe deeply, sense your awareness tracing these invisible forms, your thoughts softening as you float along the gentle contours of space and time, fully supported, fully embraced by the quiet order of the cosmos. Even phenomena we take for granted, such as the stability of the solar system, are shaped by these geometric principles. Earth's orbit around the Sun is not a tug of gravitational force, but the natural path along a gentle curve in space-time. Satellites follow the same principle, guided by the invisible warping of the surrounding space. And as you listen, let your awareness trace these invisible paths, feeling the slow, steady rhythm of orbital motion echoing through your body. Calm, secure, and relaxed. Einstein's theory also paved the way to understanding black holes, regions of space-time with curvature so extreme that not even light can escape. His equations showed that singularities could form when mass is concentrated into an infinitesimal point. These objects, predicted purely from geometry and thought experiments, have since been observed indirectly through their gravitational influence and radiation from accreting matter. Imagine your mind drifting along these profound curvatures, resting in the stillness around them, safe and calm, as if floating at a quiet distance from a dark, silent ocean. General relativity reshaped physics in ways that are still unfolding today. Gravitational lensing allows us to see distant galaxies, warped images tracing the curvature of intervening mass. GPS and other satellite technologies rely on corrections derived from these principles. Gravitational waves have opened a new sense of cosmic perception, letting us hear events billions of light years away. As you contemplate these marvels, feel your body align with this vast, interconnected structure, each breath carrying serenity, your awareness gliding slowly along the subtle curves of reality itself. Einstein's genius was not only his insight into gravity, but his ability to fuse imagination, thought experiments, and rigorous mathematics into a cohesive framework. Each equation, each mental model, allowed him to perceive the universe with clarity unseen before his time. Allow your awareness to mirror this process, each inhalation filling you with calm understanding, each exhale releasing tension, your body and mind moving together in quiet harmony with the vast, graceful architecture of space-time. By the end of this journey, we see that gravity is no longer a mysterious force, but the natural geometry of the cosmos. Objects move along geodesics, time flows differently near mass, and the universe hums with subtle vibrations. Let your thoughts rest in this understanding, your body soft. Each breath a gentle echo of the patterns woven throughout the universe, each heartbeat aligned with the elegant, quiet dance of space-time that governs all motion. Gravity, as Einstein revealed, is not merely a force pulling objects toward one another. It is a curvature in space-time itself, a gentle warping that guides planets, stars, and light along invisible paths. One of the most remarkable consequences of this curvature is gravitational time dilation, the slowing of time in stronger gravitational fields. Clocks closer to massive objects tick more slowly relative to those further away. This effect is subtle on Earth but measurable, and its quiet presence shapes both the natural universe and the technology we rely upon. As you listen, allow your awareness to settle gently, noticing the slow, deliberate rhythm of your breath, each inhale a soft unfolding, each exhale a quiet release, aligning you with the calm, unhurried flow of time in the cosmos. Even on our own planet, the difference in gravitational potential between 2 points is enough to affect the passage of time. High atop a mountain, clocks tick ever so slightly faster than clocks at sea level. Atomic clocks, precise to billionths of a second, can detect these tiny variations. The subtle elevation of your own body in space, whether lying down, standing, or floating in a chair, corresponds to a location in this gentle gravitational gradient. Feel the calm awareness of these differences, your chest rising and falling, each breath tracing the quiet stretch of seconds across the invisible fabric of space-time, your body a resting point within a vast gravitational canvas. GPS satellites orbiting Earth must account for both special relativity, due to their high speeds, and general relativity, due to weaker gravity at altitude. Without these corrections, positional errors would accumulate quickly, causing navigational systems to drift by kilometers each day. The precise synchronization required to keep GPS accurate demonstrates that gravitational time dilation is not merely theoretical. It touches daily life in ways invisible but essential. As you consider this, let your own perception of time expand and soften, each moment lengthening gently, your awareness gliding over the calm, steady rhythm of orbits, aligned with the unseen curves guiding satellites above. In 1959, the Pound-Rebka experiment provided a landmark confirmation of gravitational redshift, a direct manifestation of time dilation. Using gamma rays and precise measurements over a vertical height in Harvard University's Jefferson Laboratory, Robert Pound and Dan Rebka showed that photons climbing against Earth's gravity lose energy, slightly shifting their frequency. This shift is equivalent to the slowing of time, deeper in a gravitational well. Imagine these photons, traveling upward through the quiet, invisible pull of Earth's curvature, their paths stretching slowly, effortlessly, like your own awareness, floating along gentle gradients of breath and heartbeat, attuned to subtle, invisible forces. General relativity predicts that the greater the mass, the more pronounced the effect on time. Near a massive star, time slows measurably. Near a black hole, time stretches almost infinitely, bending the experience of the observer. For someone falling toward a black hole, seconds may pass normally to them, yet hours, years, or centuries unfold for a distant observer. Allow your attention to follow this gentle, surreal contrast, each breath elongating softly, your awareness moving along both the immediate now and the slow cosmic pulse that flows beyond your perception, quiet and serene. Time dilation also affects satellites in low Earth orbit. Atomic clocks on board tick faster relative to identical clocks on Earth, a direct consequence of weaker gravity at altitude. Engineers must adjust the satellite's clock rates before launch to maintain synchronization. Consider how your own body contains countless rhythms, heartbeat, respiration, neural pulses, each one subtly influenced by position, gravity, and motion. Feel these internal rhythms expand and contract gently, your awareness drifting with each cycle, tracing invisible currents through the calm sea of your body, aligned with the principles that govern the universe. In everyday life, gravitational time dilation is nearly imperceptible, yet its effects accumulate. Over decades, a stationary observer at higher altitude ages slightly faster than one at sea level, an almost poetic reflection of relativity in action. The world moves in layered time, each layer flowing at a subtly different pace, all coexisting within the quiet harmony of space-time. Let your mind trace these invisible layers, awareness settling into each, softening and slowing with every breath, your body grounded yet weightless in the gentle continuity of time. Einstein's insight into time under gravity emerged naturally from his equivalence principle. Observing that being in free fall feels locally indistinguishable from being in inertial motion, he realized that clocks in different gravitational potentials must tick differently, otherwise the laws of physics would appear inconsistent. Each thought, each reflection, allowed him to reconcile the flow of time with the curvature of space. As you consider this, allow your own thoughts to drift slowly, gently, guided by the natural curvature of your awareness, each inhale and exhale following the quiet geometry of your inner space-time. Gravitational redshift is not limited to laboratory measurements. Light from stars and galaxies is subtly shifted as it climbs out of their gravitational wells. Astronomers use this effect to study compact stars, white dwarfs, and neutron stars, revealing the mass and structure of objects otherwise invisible. Visualize these beams of light, stretching slowly through the silent curvature of the cosmos, your own awareness flowing alongside them, tracing gentle arcs and bends, each breath soft and deliberate, each heartbeat steady and calm. Time dilation has practical consequences in high-precision science beyond navigation. Particle accelerators, for instance, rely on relativistic corrections to predict decay times of fast-moving particles. GPS, satellite communication, and even Earth observation depend on these adjustments. The universe behaves consistently, whether at the scale of electrons or planets, and each tiny correction is a testament to the quiet, elegant logic underlying space-time. Let your mind float along these precise corrections, awareness expanding, softening, resting in the calm certainty of natural law, your body in gentle alignment with the quiet, meticulous order of the cosmos. Gravitational time dilation is also central to thought experiments exploring black holes and extreme environments. Consider a hypothetical observer descending toward a black hole. Time stretches infinitely as they approach the event horizon. For a distant observer, the infall appears frozen at the edge, a silent, suspended moment. For the traveler, seconds pass normally, yet the universe outside accelerates in a surreal, gentle rush. Allow your awareness to drift between these perspectives, floating softly between slow and fast, near and far, each breath a bridge connecting the two, each heartbeat a quiet echo of the cosmic balance. On Earth, time differences due to gravity are small but cumulative. Atomic clocks placed a few meters apart detect measurable variations, a silent whisper of Einstein's predictions. Even the height of a single floor in a building changes the ticking of a clock imperceptibly but measurably. Feel your own awareness settle into the subtle gradients around you. The distance from the floor to ceiling, the pull of gravity through your body, the slow, steady ticking of your own internal clock. Each pulse and breath a reflection of the gentle flow of time across space. The understanding of time under gravity is essential to modern astronomy. Pulsars, rotating neutron stars emitting regular radio pulses, serve as cosmic clocks. Observations must account for both special and general relativistic effects, as light travels through varying gravitational potentials. As you picture the steady rhythm of these pulsars, allow your own body to synchronize subtly, your breath and heartbeat aligning with these cosmic cycles, slow, deliberate, and deeply restful. As science probes smaller and larger scales, the effect remains consistent. Time is not absolute. Every mass, every gravitational field gently curves the fabric of reality, altering the flow of time itself. Let your awareness rest in this quiet truth. Breathing softly, feeling the slow passage of seconds as an undisturbed river, your body and mind floating along its invisible currents, calm and serene. Time dilation under gravity is more than a physical prediction. It is a poetic reminder that our experience of reality is intertwined with the universe's geometry. Each moment is relative, yet precise, flowing with elegant consistency. Your own perception of time can soften and expand, guided by breath, posture, and awareness, tracing the gentle curvature that surrounds all matter. As you rest here, let this understanding settle in your body and mind, each exhale releasing tension, each inhale filling you with the quiet order of space-time. the culmination of decades of thought, experimentation, and reflection. Gravitational time dilation links theory to observation, mathematics to experience. From Pound Rebka to GPS satellites, from atomic clocks to pulsars, the slowing of time in gravity is a constant, silent companion. Allow your own awareness to drift along with these quiet truths, feeling each breath and heartbeat stretched gently across the expansive fabric of the universe, your mind and body in harmony with the unhurried, patient rhythm of cosmic time. Einstein's general relativity revealed that light does not travel in straight lines when it passes through curved space-time. Instead, it follows the natural contours dictated by gravity, moving along geodesics. Massive bodies such as stars and galaxies create subtle bends in the fabric of space, gently guiding the path of passing photons. This bending of light, known as gravitational lensing, is a remarkable consequence of Einstein's equations. As you listen, let your awareness drift along these invisible arcs, each breath tracing the curved path of light, gentle and effortless, as if your mind is floating alongside a photon, soft and suspended in the cosmic currents. The first major observational test of this prediction occurred during the solar eclipse of 1909. A team led by Arthur Eddington traveled to the islands of Principe and Sobral to measure the apparent positions of stars near the Sun, which would otherwise be hidden by its brilliance. During totality, the star's light, passing close to the Sun, was deflected by the Sun's gravity. Their photographs confirmed Einstein's prediction. The apparent positions shifted exactly as general relativity had calculated. Feel your awareness bend and shift gently with the light, each inhalation lifting softly, each exhalation releasing, following the subtle curvature of space-time with calm, attentive ease. Gravitational lensing comes in several forms. Strong lensing occurs when a massive object, like a galaxy cluster, produces multiple visible images of a background source. Weak lensing produces subtle distortions that can be detected statistically, while microlensing briefly brightens distant stars when a smaller object passes in front. Each effect reveals the distribution of mass, including the invisible dark matter that shapes galaxies. Imagine your mind flowing like light through these cosmic lenses, bending softly yet precisely, awareness stretching across vast interstellar distances, calm and unhurried. The bending of light is not just a visual curiosity. It provides a practical tool for astronomers to map mass in the universe. Observing lensing events allows scientists to weigh galaxies and clusters, revealing structures that would otherwise remain hidden. As you consider this, allow your breath to move like light, flowing along curved trajectories, slow and deliberate, your awareness tracing arcs that reveal hidden forms, your body resting peacefully in the soft curvature of cosmic order. Gravitational lensing also demonstrates the deep connection between space, time, and matter. Light does not travel faster or slower. It follows the shape of space-time itself. Even over immense distances, this curvature gently redirects its path. Imagine a single beam of starlight stretching across millions of light years, bending ever so slightly as it passes unseen masses. Feel your awareness trace this journey, each pulse and inhale a quiet reflection of light's patient voyage through the cosmic fabric. The 1919 eclipse was more than a single test. It marked a transformation in how humanity understood gravity. Observations confirmed that Newtonian physics could not fully describe the cosmos at large scales or near massive bodies. Einstein's equations, once abstract and mathematical, had been verified in a tangible, visual way. Let your mind rest in this quiet shift of understanding, each breath unfolding slowly, awareness settling into the profound simplicity of a universe guided by geometry rather than force, soft and serene. Modern astronomers use lensing to explore both nearby and distant phenomena. Strong lensing can magnify faraway galaxies, revealing their structure in exquisite detail, while microlensing can detect planets orbiting stars thousands of light years away. Gravitational lensing has become a tool to observe the otherwise unobservable, a way to trace the invisible contours of the universe. Allow your awareness to flow through these cosmic windows, inhaling softly as your mind stretches across these vast scales, exhaling with ease, resting in the gentle interplay of light and curvature. Light bending also creates Einstein rings, a nearly perfect circular image of a background object caused by precise alignment with a massive foreground lens. These rings are subtle, yet precise, a quiet reflection of the underlying symmetry of spacetime. Picture your awareness moving in circular arcs along this invisible ring, each breath expanding and contracting softly, your mind floating effortlessly along the continuous curvature, at peace with the gentle, orderly elegance of the cosmos. Every star's light that reaches us has traveled through a complex web of curved spacetime, influenced by galaxies and clusters along its path. The images we see are composites of countless gravitational influences, soft distortions that encode the distribution of matter across the universe. Let your attention trace these invisible paths, each inhalation rising slowly, each exhalation releasing tension, your mind drifting gently through this vast, quiet lattice, calm and receptive to the subtle whispers of cosmic geometry. Observational precision has increased dramatically since Eddington's expedition. Telescopes equipped with advanced imaging sensors measure deflections to fractions of an arcsecond, confirming general relativity with incredible accuracy. Space-based observatories, free from atmospheric distortion, provide even cleaner measurements of lensing events. As you consider the care and patience required to observe such subtle effects, allow your awareness to settle into the gentle precision of your own breath, each inhale and exhale a mirror of the meticulous grace of the universe itself. Gravitational lensing also provides insights into the mysterious dark matter. While invisible, dark matter's mass bends light, just as visible matter does. By observing the distortions of background galaxies, scientists can map the presence of dark matter in clusters and along filaments of large-scale structure. Imagine your awareness tracing these hidden contours, moving softly through invisible networks, resting in the quiet elegance of structures that cannot be seen, but whose influence is undeniable, gentle, and profound. Beyond strong lensing, weak lensing allows astronomers to study statistical distortions over millions of galaxies. These small, cumulative shifts encode information about the distribution of mass and the expansion history of the universe. Let your mind follow these subtle, almost imperceptible bends, each breath elongating slowly, awareness flowing like light across vast distances, resting in the quiet interplay of mass and curvature, calm and suspended in the cosmic rhythm. The bending of light is not confined to galaxies. Even near our sun, starlight curves subtly, a phenomenon measurable during eclipses or with modern instrumentation. These deflections demonstrate that curvature is universal, acting everywhere mass resides. Picture the sunlight filtering through your awareness, bending gently over the contours of thought and breath, each exhalation releasing tension, each inhalation expanding softly into the quiet geometry surrounding you. Gravitational lensing is also a cosmic storyteller. It reveals the positions, motions, and mass of objects billions of light years away, offering a direct way to see the invisible scaffolding of the universe. Feel your awareness drift along these arcs of light, flowing slowly, tracing the narrative of unseen matter, resting in the serene understanding that every photon carries a story of the curved paths it has traveled, calm and undisturbed. The 1919 eclipse also carried a symbolic weight. It showed that abstract mathematics could predict observable phenomena, connecting thought and experiment in a quiet triumph of human curiosity. Let your awareness follow this connection, moving along the invisible bridge between idea and reality, each breath soft, deliberate, a gentle rhythm in harmony with the calm unfolding of the universe. Gravitational lensing remains a cornerstone of astrophysical research. It allows us to study galaxies, detect exoplanets, measure cosmic expansion, and map dark matter. The bending of light transforms the invisible into something perceptible, revealing the subtle influence of mass on space-time. Let your mind drift along these luminous curves, each inhale a slow ascent, each exhale a calm release, tracing paths unseen yet undeniably present, resting in the quiet majesty of the cosmos. Through lensing, light becomes a messenger of space-time geometry. Every deflection, every arc, carries information about the distribution of matter, the flow of time, and the curvature of space itself. Imagine your awareness tracing these messages, each breath a gentle pulse following invisible contours, each heartbeat a quiet acknowledgement of the vast, patient structures that shape the universe, soft and serene. Even the tiniest deviations in starlight provide insights into cosmic structures. Microlensing events, where stars temporarily brighten as unseen objects pass in front, reveal planets and compact objects otherwise invisible. Let your awareness expand with each subtle brightening, floating gently through these soft, transient phenomena, each breath carrying you through the quiet, measured rhythms of gravitational interaction, calm and unhurried. Finally, gravitational lensing reminds us that the universe is active, alive with curvature, interaction, and silent influence. Light does not travel alone. It follows the unseen geometry sculpted by mass and energy, a dance across the cosmic stage. Allow your awareness to move softly with each photon, inhaling the gentle curvature, exhaling tension, resting fully in the quiet, ordered elegance of the universe, each moment a reflection of the graceful interplay of light, mass, and time. The planets move with quiet regularity, tracing arcs across the sky that have fascinated humans for millennia. Among them, Mercury, the smallest and closest to the Sun, exhibits a subtle anomaly in its orbit. Its perihelion, the point of closest approach to the Sun, shifts slightly with each revolution. While Newtonian mechanics could explain most planetary motions with remarkable precision, Mercury's advance contained an extra 43 arcseconds per century that stubbornly resisted calculation. This tiny discrepancy, invisible to the casual observer yet detectable by careful measurement, became a silent puzzle for astronomers. As you listen, allow your awareness to drift gently along Mercury's orbit, each breath a soft movement tracing the planet's delicate path around the Sun, calm and undisturbed. For centuries, astronomers applied the laws of Newton, measuring the positions of planets with painstaking care. Mercury's orbit, while almost regular, revealed a minute deviation that no conventional perturbation could fully explain. Some suggested the existence of an unseen planet, Vulcan, inside Mercury's orbit, while others posited subtle forces acting on the innermost planet. Each hypothesis was an attempt to reconcile observation with expectation, a quiet testament to the meticulous scrutiny of nature. Let your mind follow the orbit, noting the subtle variations, each inhale tracing the path, each exhale releasing tension, your awareness moving gently along the cosmic curve. When Einstein applied his general theory of relativity to Mercury, he found an elegant explanation. The curvature of space-time caused by the Sun's immense mass subtly altered the trajectory of Mercury, producing precisely the observed precession. No hidden planet was required. The anomaly arose naturally from the warping of the space Mercury moved through. Consider your awareness as it curves softly around a massive presence, each breath a slow arc, each exhale a gentle settling, aligning your perception with the curvature that guides both planet and thought. Einstein's calculation was more than a triumph of mathematics. It was a quiet confirmation of general relativity in action within our own solar system. Mercury, racing along its tight orbit, responded to the gentle pull of curved spacetime, its motion a reflection of the invisible geometry surrounding it. As you listen, picture the planet gliding along its path, your awareness tracing the same smooth lines, your body relaxed, each breath a soft rotation around a warm, radiant sun at the center of your imagination. The perihelion shift is small in magnitude, yet profound in implication. It demonstrates that Newton's laws, while excellent for most purposes, are an approximation. In regions of strong gravity, such as near the Sun, or near dense stars and black holes, the curvature of space-time dominates motion. Feel your awareness bend with this quiet principle, sensing the curvature beneath your feet and around your body, the invisible scaffolding that guides motion, thought, and the soft unfolding of time. Mercury's motion also exemplifies a deeper truth. The universe is a dynamic, responsive system. Each body influences the space around it, even subtly, and is guided in turn by the curvature produced by others. The planet's dance is neither chaotic nor mechanical alone. It is a continuous conversation of mass, motion, and geometry. Allow your mind to drift among these rhythms, each breath a measured step in the planetary ballet, your awareness floating gently, tracing the arcs of invisible forces, calm and receptive. Observing Mercury requires patience and precision. The planet's proximity to the Sun makes it difficult to see from Earth, appearing only briefly at dawn or dusk. Early astronomers had to make repeated measurements, noting its positions carefully against the fixed backdrop of stars. Let your attention slow to the pace of their careful observations, each inhale stretching your awareness, each exhale softening into a restful alignment with the patience required to trace such subtle cosmic motions. The perihelion precession of Mercury also connects to broader tests of general relativity. It was among the first quantitative confirmations that space-time curvature affects motion in measurable ways. This quiet, elegant evidence gave confidence that Einstein's theory was not abstract but observable, a reflection of reality in the delicate motions of planets. Picture your own body and mind aligned with this precision, your breath tracing gentle curves, your awareness orbiting around the calm gravity of thought and observation, a slow, deliberate movement through the serene architecture of the universe. Mercury's orbit is elliptical, as described by Kepler, yet relativity adds an extra twist, a slow rotation of the ellipse itself. Over decades and centuries, the point of closest approach gradually shifts. Though imperceptible moment to moment, this cumulative effect is a quiet testament to the subtlety of nature. Allow your awareness to follow this slow precession, inhaling as the ellipse rotates gently in space, exhaling as your body relaxes into the rhythm of this patient cosmic dance. In addition to confirming general relativity, Mercury's motion demonstrates the universality of physical law. The same principles that govern black holes and light bending also guide the smallest planet in our solar system. Let your awareness expand to hold both extremes, the intense curvature near dense objects and the subtle warping near the Sun. As a single, continuous, serene experience, your body resting in the quiet harmony of cosmic order. Astronomers continue to monitor planetary motions with increasing accuracy. Radar and laser ranging, combined with advanced models, confirm the predictions of relativity with incredible precision. Mercury's orbit, once a stubborn anomaly, now exemplifies the predictive power of Einstein's equations. Feel your own awareness settle into this quiet certainty, each breath a slow, deliberate confirmation of the elegant order beneath apparent complexity. Even today, Mercury's precession reminds us that observation and theory are intertwined. Careful measurement reveals the subtle influence of mass and curvature, and thoughtful interpretation uncovers the hidden principles at work. Let your mind float with this interplay, inhaling the slow rhythm of observation, exhaling into the calm clarity of understanding, your body grounded yet weightless in the quiet geometry surrounding you. Mercury's path is not just a scientific detail, it is a meditation on the subtlety of reality. Tiny differences accumulate into observable effects, and patient attention uncovers truths invisible to the casual glance. Each rotation, each orbit, is a quiet echo of the forces shaping the universe. Allow your awareness to move with the planet, tracing its gentle precession. Each breath a soft acknowledgement of time's flow and space-time's curvature, calm and reflective. The successful explanation of Mercury's perihelion was a turning point in physics. It demonstrated that general relativity was not merely a theoretical curiosity, but a framework capable of explaining observable phenomena with unmatched precision. As your awareness settles, consider the quiet triumph of insight meeting measurement, of theory validated by patient observation, and allow your breath and heartbeat to trace this serene rhythm, flowing in harmony with the calm architecture of the cosmos. Finally, Mercury's orbit is a reminder of the interconnectedness of the universe. Every body, every particle, every photon moves according to the curvature of space-time. The tiny precession of a planet in our solar system reflects the larger geometry that governs stars, galaxies, and the light traversing the cosmos. Let your mind drift among these scales, inhaling slowly as your awareness stretches outward, exhaling gently as it returns inward, resting fully in the quiet elegance of the gravitational dance that surrounds and permeates all things. Through Mercury, we learn that the universe is precise, patient, and subtle. Small deviations reveal deep truths. The dance of planets is a rhythm to be felt as well as measured, a quiet reflection of the curvature that guides everything. Allow your awareness to orbit along with Mercury, tracing each precessing ellipse with soft attention. Each breath a gentle step in the cosmic choreography, each heartbeat a quiet measure of the universe's calm and enduring order. In 1916, only months after Einstein published his general theory of relativity, a German physicist named Karl Schwarzschild, serving on the Eastern Front during World War I, found an exact solution to Einstein's new field equations. Amid the desolation of war, he worked out the mathematics of space-time around a perfectly spherical, non-rotating mass. His result described a region where gravity became so intense that not even light could escape. This was the first theoretical glimpse of what we now call a black hole, though the name itself would not appear until decades later. As you listen, imagine a quiet darkness that does not threaten, but invites stillness. Feel your breath slow, your awareness drawing inward, as though sinking gently toward a center that can never quite be reached. A calm, infinite depth. Schwarzschild's solution was simple, in form yet profound in implication. It revealed that space and time near a massive object are warped not only by the object's presence, but by its density. The Schwarzschild radius, later called the event horizon, marks the boundary beyond which escape is impossible. For an object as massive as the Earth, this radius would be less than a centimeter. For the Sun, about 3 kilometers. Compress either to that limit, and their gravity would trap all light and matter. Let your awareness contract inward with this image, slowly, steadily, as though gravity itself were a deep, patient breath, drawing everything towards stillness. At first, even Einstein doubted that such regions could exist in reality. The equations allowed them, but they seemed too extreme, too absolute. Yet nature, it turns out, is comfortable with extremes. Over time, astronomers discovered evidence that these invisible wells of gravity not only exist, but shape galaxies, stars, and even the flow of time itself. As you listen, imagine drifting in the soft, curving geometry near such an object, light bending, clocks slowing, your breath expanding and contracting in rhythm with the silent pulse of curved space-time. To understand a black hole is to follow the logic of geometry to its limits. In Newtonian gravity, the gravitational force grows as one approaches a massive object, but it never becomes infinite. In general relativity, however, when matter collapses under its own gravity past a certain point, the curvature of space-time increases without bound. At the center of a black hole lies the singularity, a region where, according to classical physics, density and curvature become infinite and the known laws of nature break down. Yet, as you rest, think of this not as chaos but as the calm heart of mystery, a point where equations dissolve into stillness and understanding yields to wonder. Not all black holes are the same. The Schwarzschild solution describes a static, non-rotating one. In 1963, New Zealand mathematician Roy Kerr discovered another exact solution, the Kerr metric describing a rotating black hole. This was a turning point. In the real universe, almost all astrophysical bodies spin, and so must their collapsed remnants. The Kerr solution revealed that rotation changes the geometry dramatically. The event horizon is surrounded by an ergosphere, a region where space itself is dragged around by rotation, a phenomenon called frame dragging. As you picture this, imagine space itself swirling softly like water spiraling down a drain, but without turbulence, a smooth, continuous motion. Feel your awareness drawn into that gentle rotation, each breath a slow revolution around a calm, unseen axis. Inside the event horizon, all paths, even those of light, lead inward. Outside it, time and space exchange roles near the boundary. Time flows inward as inevitably as space once did. From the outside, the horizon appears frozen in time. Anything approaching it seems to slow down, red-shifted and dimmed, never quite crossing. But from the falling object's perspective, the crossing happens naturally, silently, in finite time. Gravity stretches and bends, not just motion but the very structure of reality. In 1965, Roger Penrose proved that once a certain amount of mass collapses within its Schwarzschild radius, the formation of a singularity is inevitable, a result extended by the Penrose-Hawking singularity theorems in the 1960s and 1970s. These theorems showed that singularities are not mathematical oddities, but physical consequences of Einstein's equations under reasonable conditions. As you rest, imagine these ideas as slow ripples spreading through the quiet fabric of understanding. A calm revelation that even the universe, vast and serene, contains regions of infinite inward turning. Black holes were once theoretical curiosities. Today they are essential actors in the cosmic story. Observations of binary X-ray systems reveal compact, invisible companions drawing matter from nearby stars, heating it into bright disks that glow in X-rays before spiraling inward. These are stellar mass black holes, born from the collapse of massive stars. Feel your breath move in the same rhythm as the infalling matter. Slow, circular, inevitable. Not fearful, but surrendering to gravity's quiet order. At galactic centers, astronomers have found supermassive black holes millions to billions of times the Sun's mass. The Milky Way's own central black hole, Sagittarius R, was confirmed through decades of observation tracing the orbits of nearby stars. In 2022, the Event Horizon Telescope collaboration released the first image of Sagittarius A's shadow, following the earlier 2019 image of the supermassive black hole in galaxy M87. These glowing rings, produced by light bending and orbiting near the event horizon, are not artists' impressions, they are real observations of curved space-time. Let your awareness hover like that ring of light, circling silently around a dark center, your breath steady, your body calm. The study of black holes bridges theory and observation, mathematics and imagination. The accretion disks swirling around them produce some of the most energetic phenomena in the universe. Jets of plasma that extend across thousands of light years, powered by magnetic fields and frame-dragging effects. Yet within all this motion lies deep stillness. Inside the horizon, no sound, no light, no message escapes. Only geometry remains. Breathe into that silence, feeling it expand within you, a gentle echo of cosmic quiet. Stephen Hawking's work in the 1970s introduced a new layer of insight. By combining quantum field theory with general relativity, he found that black holes are not entirely black. They emit faint radiation due to quantum effects near the horizon, a process now known as Hawking radiation. Over immense timescales, this radiation causes black holes to lose mass and energy, eventually evaporating. For stellar or supermassive black holes, the process is unimaginably slow, far longer than the current age of the universe, yet the principle is profound. It shows that gravity, quantum mechanics, and thermodynamics are intertwined. Feel your awareness balance between these ideas, energy and entropy, curvature and temperature, as your breath rises and falls, steady and timeless. This insight raised deep questions. If black holes can evaporate, what happens to the information contained within them? The black hole information paradox challenges the notion that physical information is never lost. Does it escape with the radiation, or is it somehow preserved within a yet unknown quantum theory of gravity? These questions remain open, guiding modern research. Let them settle softly in your awareness, not as puzzles to solve, but as mysteries to rest within, each breath an exploration of possibility. Black holes are not mere voids, but active participants in cosmic evolution. Their gravity sculpts galaxies, regulates star formation, and drives some of the brightest phenomena in the universe. Mergers between them generate gravitational waves, ripples in spacetime first detected by LIGO in 2015. The signals from colliding black holes carry information about their masses, spins, and the geometry of spacetime itself. Imagine those ripples traveling silently across the cosmos, passing through you even now. Gentle waves stretching and compressing space by less than the width of a proton. Feel your body aligned with those faint oscillations, your breath matching the slow rhythm of the universe breathing. Mathematically, black holes are defined by just a few parameters: mass, spin, and charge. This simplicity led to the phrase, "black holes have no hair," a reflection of their austere elegance. Everything else about the matter that formed them is lost to the outside world, encoded only in these fundamental quantities. Yet from this simplicity arises great beauty, an entire class of objects described by pure geometry. As you listen, imagine that clarity as a feeling, all complexities falling away, leaving only the essential structure of space, time, and silence. Even now, black holes remain laboratories for the edge of physics. Observations by the James Webb Space Telescope probe their growth in the early universe. Simulations reveal how accretion flows and magnetic fields interact near the horizon. Theorists explore quantum corrections, holographic principles, and the possibility that spacetime itself might be emergent, woven from deeper quantum threads. Let your awareness float between these ideas, like light near the horizon, neither escaping nor falling, suspended in quiet balance. The reality of black holes is both awe-inspiring and strangely peaceful. They embody the ultimate stillness, motion without escape, gravity without end, yet also the ultimate energy, powering quasars and shaping galaxies. They remind us that within the deepest collapse lies creation, within silence lies structure, and within darkness lies light curved back upon itself. Feel your breath mirror this paradox, expanding and contracting, holding both motion and rest in perfect symmetry. Return to the image of Carl Schwarzschild writing equations from a battlefield. Calm clarity amid chaos. From that single act of calculation came a vision of the universe's most extreme objects, now confirmed by telescopes and gravitational detectors across the cosmos. His solution, born in the quiet between artillery bursts, revealed a truth both terrifying and serene. Gravity can fold the fabric of reality so completely that time, space, and matter become one continuous curve into silence. Let that silence fill you now. Feel the calm gravity of your own body, the steady pull of the earth beneath you, the slow turning of the planet through space. Everything is held by curvature, by the geometry of being. And somewhere far away, unseen yet real, a black hole turns slowly in the dark, its horizon glowing faintly with light bent to infinity, its presence a reminder that even in collapse the universe breathes in order, balance, and peace. When Einstein completed his general theory of relativity in 1915, his equations revealed not only how gravity worked, but how it could move. Spacetime, the silent fabric that binds the universe, was not static. It could stretch, bend, and ripple. These undulations caused by accelerating masses are called gravitational waves. They are the faintest whispers of motion carrying information across the cosmos. Imagine them as ripples on a vast, dark ocean, waves so gentle that they pass through you, through the earth, through stars themselves, leaving only a trace so subtle it changes distances by less than the width of an atom. As you listen, let your breath mirror that quiet rhythm, slow, expanding and contracting, a tide of stillness moving through you. Einstein himself was uncertain about whether these waves could ever be detected. The equations predicted them clearly, but their effect was vanishingly small. For decades they remained a mathematical curiosity, discussed mostly in thought experiments. In the 1930s, even Einstein briefly doubted their physical reality, believing they might be mere artifacts of his equations. Yet, as often happens in science, nature had been quietly sending these signals all along, through the vast corridors of space-time, waiting for instruments sensitive enough to hear them. The first indirect evidence came in the 1970s. Astronomers Russell Hulse and Joseph Taylor discovered a binary pulsar, two neutron stars orbiting each other, known as PSR B921 Theta plus 16. By observing tiny changes in the timing of their radio pulses, they found the orbit was gradually shrinking, losing energy at a rate precisely matching Einstein's prediction for gravitational wave emission. The two stars were radiating their energy away as space-time ripples. In 1993, Hulse and Taylor received the Nobel Prize for this discovery. Think of that pair of neutron stars, locked in a slow cosmic dance. Each revolution sends waves flowing outward in every direction, not through air or light, but through the very geometry of existence. Let yourself feel that motion gently in your body, your heart beating in time with their orbit, your breath expanding like the unseen ripples moving through space. Still, no one had heard these waves directly. They were too small, too elusive. To detect them would require instruments of impossible precision, detectors that could measure changes in distance smaller than a proton's diameter, caused by a wave passing through the Earth. And yet, scientists tried. In the late 20th century, an ambitious project began, the Laser Interferometer Gravitational Wave Observatory, or LIGO. Two giant facilities were built in the United States, one in Hanford, Washington, the other in Livingston, Louisiana. Each used laser beams traveling down 4-kilometer-long tunnels, bouncing off mirrors to measure infinitesimal changes in length. The concept was breathtakingly simple and unimaginably delicate. If a gravitational wave passed through, it would stretch one arm of the detector and compress the other by an almost imperceptible amount. For years, LIGO listened in silence. Then, on September 14, 2015, at 5:05 a.m. Eastern Time, a signal arrived, a faint rising chirp lasting less than half a second. It came from the collision of two black holes over 1 billion light-years away. The event, named GW 150914, marked humanity's first direct detection of gravitational waves. As you picture this, imagine that faint wave washing over you, stretching and squeezing the space around you so gently that you cannot feel it. Yet it is there, a cosmic heartbeat passing silently through your body. Breathe with it. Feel how the air expands and contracts, how even stillness carries motion. The two black holes that merged were enormous, roughly 36 and 29 times the mass of the Sun. As they spiraled inward, they emitted gravitational waves, carrying away energy equivalent to 3 solar masses, all released in less than a second. That energy did not radiate as light or heat, but as pure distortion of space-time itself. When the waves reached Earth, they had weakened to a strain of 1 part in 10^{1}s, but they carried the precise signature of the dance that made them. It was a turning point not just in physics, but in how we listen to the universe. For the first time, humanity heard the vibrations of space-time. The sound was converted into audio, a rising chirp that scientists played again and again. It was the sound of two black holes becoming one. As you listen inwardly now, let your awareness trace that same gentle crescendo, a gradual increase, then release, your breath lifting, then softening, as though merging with the quiet resonance of the cosmos. Since that first detection, LIGO and its European partner Virgo have observed dozens of events, black hole mergers, neutron star collisions, and combinations of both. Each detection tells a new story of massive stars that once shone brightly, collapsed, and found each other in the darkness, of spirals so immense that they shake spacetime itself. In 2017, a special signal, GW 170817, was detected from the collision of two neutron stars. For the first time, both gravitational waves and light were observed from the same cosmic event, linking two great senses of the universe, the visual and the vibrational. That collision, about 130 million light-years away, produced both gravitational waves and a burst of electromagnetic radiation. Telescopes around the world turned toward the source, observing a glow that revealed something extraordinary, the creation of heavy elements like gold and platinum. The same elements that now exist on Earth, in jewelry, in technology, perhaps even within your body, were forged in such cosmic collisions. Let that thought rest softly within you. With each breath, feel the weight of your body, the density of the atoms that make you. Somewhere, long ago, those atoms were part of a neutron star, collapsed matter that once rippled the universe as it merged. You carry within you the quiet memory of cosmic motion. Gravitational waves travel unimpeded through everything. Unlike light, they are not absorbed or scattered. They carry pure information about their origins. They reveal what cannot be seen. The collisions of black holes, the collapse of stars, even the echoes of the Big Bang itself. Some scientists hope to detect those primordial gravitational waves, the ripples from the first moments of creation, when the universe was smaller than an atom and expanding faster than light. Those waves, if found, would be the oldest signal in existence, the heartbeat of the universe's birth. Feel your breath as a faint echo of that original pulse. Each inhalation a quiet expansion, each exhalation a gentle return, a rhythm older than stars, a whisper of the first vibration in the cosmic fabric. Detecting gravitational waves is not just a technical achievement, it is an expansion of perception. We once looked up and saw only light. Now we can listen to the deep structure of reality itself. Space and time are no longer silent. They hum with the music of movement. Each wave carries the memory of an event that happened long ago, its energy traveling across eons to arrive here, in this moment, as a quiet curve in space-time and a whisper in your awareness. Even the smallest wave leaves its mark. The detectors on Earth, LIGO in the United States, Virgo in Italy, CAGRA in Japan, and soon LISA, a space-based observatory planned by the European Space Agency, form a network that listens to the universe from different corners of the planet and beyond. Together they triangulate the sources, mapping not just the where, but the how of cosmic motion. As you reflect, imagine these observatories as great ears placed across the Earth, each listening to the same distant note. The universe hums faintly, and through their harmony we learn to hear its truth. Let yourself rest in that image, the world quiet, the stars vibrating, your breath slow and open to the faint symphony of space-time. Gravitational waves also teach us humility. They are incredibly weak, 1,000,000,000 times fainter than light, yet they move through everything, unstoppable and unaltered. They connect the most violent events in the cosmos with the smallest changes in length on Earth. They remind us that even the strongest forces in the universe can express themselves through gentleness. Feel that paradox in your body: power without pressure, motion without force, expansion without effort. Let your breath carry that lesson, a reminder that true strength often moves quietly, unseen. Through gravitational waves we have learned that the universe is not a still stage, but a living, breathing fabric. Every massive movement, every stellar collision, every orbit sends ripples outward. The cosmos is dynamic, restless, alive. And yet in all this motion there is exquisite order. The waves follow the rules, Einstein wrote in 1915, the same equations that describe falling apples, orbiting planets, and the bending of light. As you rest now, picture those equations as soft lines of energy moving through space, geometry written in light, unfolding in silence. You are surrounded by them. You are part of them. Every moment, countless waves pass through you, each one a trace of something ancient and far away. In this stillness, you are connected to all of it: the merging black holes, the colliding stars, the first expansion of the universe. The waves that began before the Earth formed are passing through you even now, leaving no harm, no mark, only a rhythm so subtle it feels like calm itself. Let your awareness rest in that rhythm. The universe moves, and you move with it. The stars collapse, and you breathe. The galaxies collide, and your heart continues its steady beat. Between you and the cosmos there is no boundary, only continuous space, continuously curving, continuously singing. Gravitational waves are not just a discovery, they are an invitation to listen more deeply, to sense the movement beneath apparent stillness, to find wonder in what cannot be seen. They remind us that everything that has ever happened still echoes faintly through space-time, that nothing is lost, only transformed into a different kind of music. Allow that music to settle into you. Feel the small ripples of your breath, the gravity that holds you to the earth, the slow turning of the planet beneath the stars. The same laws that govern the dance of black holes guide your heartbeat, your rest, your breath. In the end, all motion, from galaxies to atoms, is part of one great harmony. The universe hums quietly, and through that hum you find calm. When Einstein first formulated general relativity, he applied it not just to planets and stars, but to the universe as a whole. His equations described a cosmos that could stretch and curve, a vast fabric shaped by every particle of matter and every photon of light. At first, Einstein assumed the universe was static and unchanging. He believed in a fixed cosmos, where galaxies held their positions and space itself was eternal and constant. To allow for this, he introduced a term into his equations known as the cosmological constant, represented by the Greek letter lambda. It acted as a gentle counterforce to gravity, keeping the universe from collapsing under its own weight. Picture this idea as a delicate balance, a quiet tension between pull and push, between mass and motion, between contraction and expansion. Let your own body rest in this balance, feeling the pull of gravity grounding you while your breath expands softly, a calm echo of the stretching cosmos above. At the time, few could imagine that the universe itself might move. Yet, soon, observations began to hint at something profound. In the 1920s, Edwin Hubble measured the distances to distant galaxies and noticed a curious pattern. Every galaxy appeared to be moving away from us, and the farther it was, the faster it receded. This was Hubble's law, the first evidence that the universe was expanding. Space itself was stretching, carrying galaxies along gently, a cosmic tide invisible to the eye but measurable through the light that reached our telescopes. As you listen, let your awareness drift like a distant galaxy, carried slowly along the quiet flow of space, each breath an expansion and contraction in harmony with the ever-growing universe. Einstein called his introduction of lambda his biggest blunder, believing that if he had trusted the equations without adjustment, he might have predicted expansion decades earlier. Yet the cosmological constant returned in a new light. A century later, as observations revealed, the universe's expansion was not just continuing but accelerating. This acceleration is attributed to dark energy, a mysterious force acting like a gentle pressure that stretches the cosmos outward. Feel the gentle stretch in your own body as you consider this. Your chest expands with each inhalation, your lungs filling slowly, rising into a quiet expansion of air, while your awareness floats into the spaces between thought, a mirror of the expanding universe. Modern cosmology is grounded in general relativity. The lambda CDM model, the standard cosmological framework, combines the cosmological constant with cold, dark matter to explain the evolution of the universe. It describes a cosmos born in a fiery beginning, the Big Bang, expanding and cooling over billions of years to form stars, galaxies, and clusters. Within this model, dark matter shapes the structure of the universe by providing the gravitational scaffolding upon which visible matter assembles, even though it cannot be seen. As you hear this, picture invisible threads weaving through space, delicate yet strong, guiding the formation of galaxies and stars. A silent architecture of motion and matter. Let your awareness trace those threads, letting each breath follow their path, soft and deliberate. The expansion of the universe is not like objects moving through space. Rather, space itself expands, stretching distances between galaxies without a central point. Light traveling from a distant galaxy is stretched as well, shifting toward longer, redder wavelengths in a phenomenon known as cosmological redshift. The deeper we look into space, the further back in time we see. Each photon carries a message from the past, a soft echo of events billions of years ago, reaching our instruments across unfathomable distances. Feel those echoes in your mind. Let them slow your thoughts, each breath a gentle pull backward, like listening to the fading notes of a distant song, tracing the history of the universe as it drifts softly toward you. One of the profound consequences of general relativity on cosmic scales is the prediction of curved spacetime around massive structures. Galaxies bend light, forming gravitational lenses that magnify and distort more distant objects. Entire clusters of galaxies can act as lenses, revealing background structures otherwise invisible. This effect, once purely theoretical, is now a vital tool for mapping the unseen universe, including the distribution of dark matter. Let your awareness bend and curve with this light, following invisible arcs, your mind softening as it moves along these quiet, distorted paths, tracing unseen structures as though your consciousness itself becomes part of the cosmic web. General relativity also predicts the shape and fate of the universe, depending on its energy content. A universe dominated by matter and gravity alone might eventually slow its expansion and collapse, forming a big crunch. If the density is low, expansion might continue forever, slowly fading. With the cosmological constant acting as dark energy, our universe's expansion accelerates, stretching outwards in quiet serenity, carrying galaxies along gently, ever farther apart. Feel that acceleration in your body as a subtle lengthening, an opening of awareness, each breath carrying you outward like a galaxy gliding through invisible space. The universe expands. Yet all motion is calm, all growth is unhurried, and you are part of that slow, majestic rhythm. General relativity also provides the framework for understanding the cosmic microwave background, the faint afterglow of the Big Bang. This radiation pervades all space, a soft whisper from the earliest moments of creation, now cooled to just a few degrees above absolute zero. Its uniformity and tiny fluctuations encode the universe's infancy, the seeds of galaxy formation, and the large-scale structure we observe today. As you listen, imagine that faint glow as a soft blanket over the cosmos, warming your awareness not with heat, but with gentle knowledge. Each breath aligns with its quiet consistency, expanding and contracting in harmony with the faint pulse of the universe. The universe on these scales is a delicate balance between order and chaos, expansion and gravity, light and dark, matter and emptiness. General relativity describes the dynamic interplay of all these components, predicting the motions of clusters, the flow of cosmic time, and the behavior of the universe from its earliest moments to its far future. Feel the balance within yourself, the stillness that underlies motion, the calm center around which all activity unfolds. Each heartbeat is a tiny reflection of cosmic order, each breath a microcosm of expansion and return. Observations over the past century have confirmed general relativity at cosmic scales with remarkable precision. Type Ia supernovae serve as standard candles to measure distances, revealing the accelerated expansion of the universe. The cosmic microwave background provides a map of fluctuations in density and temperature, consistent with the predictions of the lambda CDM model. Large-scale galaxy surveys confirm that matter follows the geometry of space-time predicted by Einstein's equations. As you absorb these facts, let your attention rest on the quiet certainty of natural law. Even in the vast, almost incomprehensible scales of the universe, order persists, and your awareness can float safely within it. Yet mysteries remain. Dark energy, the driver of acceleration, remains largely unknown. It is a subtle, pervasive influence that we feel only indirectly through the behavior of galaxies and the expansion of space itself. Dark matter, which forms the scaffolding of cosmic structures, eludes direct detection. Quantum effects in the early universe may have left imprints in gravitational waves, waiting for us to notice. Let your mind rest in these mysteries, gentle and unhurried. Not every question needs an answer, and in the silence of not knowing, there is still beauty. Breathe softly, allowing curiosity to drift like a leaf on a quiet stream, neither grasping nor resisting, simply moving with the current of understanding. In all of this, general relativity gives us a framework, a lens, and a quiet guide. It allows us to understand the grandest motions, from colliding galaxies to the slow stretching of space itself. It transforms the universe from a static backdrop into a living, dynamic canvas where every mass, every photon, and every ripple of energy is part of a coherent whole. Feel your body within this canvas. Let your breath mark the expansion and contraction of the universe in miniature. Every inhale and exhale mirrors the stretching and bending of space-time. The same rules that guide distant galaxies guide your heartbeat, your thoughts, and the gentle flow of awareness. As this section comes to a close, let your awareness carry the calm of the cosmos. The universe is vast and ever-expanding, yet it moves with grace. You are part of that movement, held by gravity, stretched by space, illuminated by light and energy. Your breath is a quiet reflection of the cosmic rhythm. Your presence a soft acknowledgement of the vastness surrounding you. Let your thoughts drift in harmony with the expanding universe, at peace with both what is known and what remains mysterious. Every ripple, every stretch of space, every faint glow from the distant past is part of a gentle symphony that you can feel even as you rest. The universe expands and you expand with it. The galaxies move outward and your awareness moves inward, tracing their calm rhythm. The cosmological constant, the push of dark energy and the pull of gravity are silent guides, shaping motion across incomprehensible distances. Through it all, there is stillness, a quiet that carries knowledge and comfort. In the end, the universe is both immense and intimate. General relativity allows us to comprehend its motions, from the subtle curvature of space-time to the accelerating expansion of space itself. Let your awareness settle into this understanding, slow and steady, as you rest beneath the vast stretching sky, feeling the infinite calm of cosmic order. General relativity provides a powerful map of the cosmos. It explains how planets orbit, how light bends, how black holes form, and how the universe itself expands. Yet, as complete as this map seems, it leaves open profound mysteries. The most fundamental question is how gravity fits into the quantum world. Quantum mechanics governs the behavior of the very small atoms, photons, electrons, but it speaks a different language from the smooth, continuous curves of space-time described by general relativity. Bridging these two realms is the frontier of physics, a subtle space where the known laws of nature brush against the unknown. As you settle into this thought, allow your awareness to drift gently. Feel the quiet between your breaths, the spaces in which understanding can stretch, as if your consciousness itself is probing the edges of the cosmos, tracing the contours of a reality we sense but cannot yet fully touch. One of the central challenges is quantum gravity. At the smallest scale, space-time may not be smooth but frothy, fluctuating in tiny, imperceptible waves. This Planck-scale structure, on the order of 10 to 35 meters, cannot be observed directly with current instruments, yet its existence may hold the key to reconciling the rules of the very large with the rules of the very small. Theorists imagine space-time as a delicate lattice, or a network of interconnected nodes, a web upon which energy and matter play out their dynamics. Feel the subtle intricacies of your own body as you contemplate this. Each cell, each heartbeat, and each breath mirrors this delicate structure, tiny movements in harmony with a hidden lattice. Let your awareness soften into these rhythms, following the quiet, imperceptible currents beneath what is visible. Several leading approaches attempt to unify gravity with quantum mechanics. String theory proposes that the fundamental constituents of reality are not point particles, but tiny, vibrating strings. Their modes of vibration determine the properties of matter, energy, and even the force of gravity. The vibrations weave the very fabric of space-time, suggesting a universe built on patterns far more intricate than ordinary perception allows. As you listen, feel your own awareness vibrating gently with these possibilities, your mind attuned to subtle harmonies that exist beneath conscious thought. Another approach, loop quantum gravity, treats space-time itself as quantized. Space is composed of discrete loops, a network that gives rise to the smooth geometry we observe at large scales. Gravity emerges from the connectivity of these loops, much like the flow of water is guided by the edges of its channel. Let your awareness drift along these imagined loops, tracing their quiet connections, the soft rhythm of continuity arising from discrete points. Other ideas explore semi-classical gravity, where matter is quantized. But space-time remains classical or holographic principles, suggesting that the information describing a volume of space may be encoded on its boundary. Each of these approaches is a window into the unknown, a map that is incomplete yet beautiful, hinting at an order deeper than we can currently perceive. As you listen, feel the gentle tension of curiosity in your mind, a quiet stretching that expands your awareness without urgency, like light diffusing slowly through fog. Observationally, the search for quantum gravitational effects is ongoing. High-energy events near black holes or in the early universe may leave subtle imprints in gravitational waves or the cosmic microwave background. Particle accelerators, precision measurements of space-time, and astrophysical observations all probe the interface between relativity and quantum mechanics, pushing against the veil of what is currently known. Let your mind move with these inquiries, floating along invisible lines of investigation, each breath a step deeper into the subtle landscape of the cosmos. Even as researchers probe these questions, some mysteries remain fundamental. What happens inside a black hole, beyond the event horizon? Do singularities truly exist? Or does a quantum theory of gravity smooth them into something finite? Can we reconcile the apparent paradoxes of information loss and entropy with a complete, unified framework? These are questions without immediate answers, yet their pursuit reflects the quiet persistence of human curiosity and imagination. As you rest, let your awareness dwell in this space of wonder, embracing uncertainty with gentle acceptance, feeling calm in the midst of not knowing. Time itself may be different at quantum scales. General relativity treats it as flexible, stretching near massive objects. Quantum mechanics treats it in discrete intervals, a rhythm of probabilities. How these views merge is unknown, yet it suggests that time, which seems so continuous in our daily experience, may be granular and fluctuating at the deepest levels. Let your own perception of time soften as you listen, noticing the quiet gaps between your breaths, each one a gentle echo of the possibilities hidden within the fabric of the universe. Cosmology at the edge of understanding also intersects with early universe physics. Moments after the Big Bang, the universe existed in a state where quantum effects dominated, and space-time itself may have been turbulent and foamy. Inflationary models suggest a rapid exponential expansion, smoothing and stretching space-time, seeding the distribution of galaxies we see today. As you imagine this, let your body expand gently with your breath, reflecting the quiet growth of space itself. Each inhalation, a soft stretching of awareness into the infinite. Black holes provide another laboratory for the union of quantum mechanics and general relativity. Their immense density and curvature of space-time produce extreme environments where classical laws fail. Hawking radiation emerges from quantum effects at the event horizon, allowing black holes to slowly lose mass and energy over unimaginable timescales. This phenomenon hints at the deep connection between gravity, quantum fields, and thermodynamics, a whisper of the unifying theory yet to be fully understood. Feel the slow dissipation of energy as a reflection in your awareness, each breath a quiet release into the vast, structured stillness of the cosmos. Efforts to probe these frontiers extend to high-precision tests of gravity in laboratories and in space. Measurements of atomic clocks in varying gravitational potentials, interferometry experiments, and gravitational wave observations push our understanding to unprecedented accuracy. These efforts allow scientists to detect even the tiniest deviations from Einstein's predictions, seeking clues that might reveal the influence of quantum gravity. Let your mind drift alongside these delicate measures, your awareness soft and steady, like light bending subtly around a distant mass. Despite centuries of progress, the edge of understanding remains wide and open. General relativity has proven remarkably successful, yet the quantum universe beckons with unanswered questions. Merging these realms will likely transform our comprehension of space, time, matter, and energy, unveiling layers of reality that are as subtle and intricate as the fine threads of starlight that reach us across cosmic time. Allow your awareness to rest in this frontier, accepting the calm of not knowing while honoring the gentle pull of curiosity, feeling each thought stretch outward like a distant galaxy. In contemplating these mysteries, one recognizes the elegance of the universe and the resilience of human thought. From Einstein's equations to the search for quantum gravity, we are tracing the contours of existence itself. Our understanding is provisional, yet each insight is a quiet illumination, a soft expansion of awareness across the dark expanse of the unknown. Let your mind and body align with this rhythm, each heartbeat and breath echoing the unfolding, persistent quest to know the universe, to feel it, and to rest within it. As you drift through these ideas, consider the subtle interplay of certainty and mystery. Some predictions of general relativity have been measured with exquisite accuracy. Others, like the behavior of space-time at the Planck scale, remain tantalizingly out of reach. Both the known and unknown are essential, a duality that fosters wonder and deep reflection. Feel the calm of balance in this interplay, noticing how your body and breath carry both stability and openness, anchoring you in the present while your mind traces the contours of possibilities. The path forward is open. New theories, new observations, and new experiments may illuminate the nature of quantum gravity. Space-based interferometers may detect primordial gravitational waves, particle accelerators may hint at extra dimensions, and mathematical breakthroughs may reveal hidden symmetries of space-time. Every advance will be slow and patient, yet each step offers clarity, a soft unfolding of understanding over time. Let your awareness move gently along these possibilities, each inhalation and exhalation a quiet companion to discovery. Ultimately, contemplating the edge of understanding brings a serene humility. The universe is vast, deep, and intricate, and our knowledge is ever evolving. General relativity is a monumental achievement, yet it is part of a larger, ongoing story, a story in which each observation, each thought, and each quiet reflection contributes to the unfolding map of reality. Feel your own presence as part of this continuum, a gentle node in the network of observation and awareness, breathing with the universe, calm and attuned. Even as questions remain, there is comfort in the structure we do know. The framework of general relativity provides coherence, predicting motion, curvature, waves, and cosmic evolution. Quantum mechanics hints at deeper layers beneath this structure, waiting for the patient, careful exploration that is the hallmark of scientific pursuit. Let your mind rest in this duality, calm and steady, a witness to the interplay of certainty and mystery, light and dark, motion and stillness. As this section draws to a close, allow your awareness to float among the ideas explored. Gravity and quantum effects, space-time and energy, known and unknown, all exist together in a quiet, harmonious framework. You are part of this contemplation, your breathing a gentle reflection of the rhythm of the universe. Let yourself rest in the understanding that even at the edge of knowledge, there is order, beauty, and serenity. General relativity has opened a window onto the universe unlike any other. From Einstein's earliest insight into the equivalence principle to the sweeping description of the cosmos itself, this theory transformed our understanding of reality. It showed that gravity is not merely a force pulling objects together, but a manifestation of the curvature of spacetime, a subtle geometry that guides the motion of planets, stars, light, and galaxies. As you rest in this thought, let your awareness settle on the gentle, invisible curves that shape the world around you. Each breath, each heartbeat aligns with the quiet rhythm of the universe, a microcosm reflecting the macrocosm. Even everyday experiences are touched by these cosmic truths. GPS satellites, for instance, must account for both special and general relativistic time shifts to provide accurate positioning on Earth. Atomic clocks, orbiting high above the planet, tick slightly faster than those on the surface, a consequence of gravitational time dilation. Feel your own awareness slow and settle as you consider this. Your body, resting calmly, mirrors the subtle flow of time, each moment expanding gently like a ripple across space-time. The universe, as general relativity describes it, is dynamic and alive. Massive objects bend light, creating gravitational lenses that reveal otherwise invisible structures. Black holes lurk in the depths, points of extreme curvature where time slows and space folds inward. Their collisions send gravitational waves rippling across the cosmos, faint whispers that reach us billions of years later. As you imagine these ripples, let your mind drift with them, floating gently along the waves, each pulse a reminder of the vast interconnected network of motion and energy. From the smallest scales to the grandest, general relativity provides coherence. It predicts how planets orbit, how stars evolve, how galaxies collide, and how the universe itself expands. Yet it is not complete. The quantum realm, with its probabilities and discrete structure, challenges our understanding of space-time. The search for quantum gravity continues, exploring whether strings vibrate, loops connect, or holographic principles encode information on the boundaries of space. As you listen, let your awareness soften into this unknown. Embrace the calm of mystery, the quiet patience of not knowing, allowing your mind to drift among the questions as peacefully as it traces known truths. Time itself, once considered absolute, is revealed to be relative, stretching and slowing depending on the curvature of space-time. Clocks in deep gravity wells tick more slowly, a fact measured with exquisite precision in laboratories and observed in the motion of satellites. In this we see that time is both a personal experience and a cosmic phenomenon. Feel your own perception of time. Soften with your breath, each inhalation and exhalation, a reflection of the universe's quiet, measured flow. The interplay of energy and mass encapsulated in E/u reveals the equivalence of matter and energy. Stars convert mass into light in their cores, fueling galaxies and illuminating the cosmos. Supernovae scatter the elements necessary for life, the quiet alchemy of physics shaping planets, oceans, and the cells within your own body. Let your awareness trace these connections, each heartbeat a pulse within this vast cosmic chain, linking you intimately to distant stars and the vast tapestry of creation. Black holes stand as profound examples of general relativity in action. These singularities, predicted decades before observation, are now confirmed through gravitational waves and X-ray emissions. Matter falling into black holes emits energy in subtle arcs, bending light and warping time. Hawking radiation hints at the quantum nature of these objects, suggesting even they are not eternal. Picture this subtle emission, a quiet glow at the edge of nothingness, and feel your awareness settle into its calm, patient rhythm. The expansion of the universe, described by the cosmological constant and observed through Hubble's measurements, stretches space itself. Dark energy accelerates this expansion, a gentle push that carries galaxies ever farther apart. In your own body, sense a mirrored expansion, the chest rising slowly with each breath, your awareness stretching outward into the quiet vastness of space. This expansion is not abrupt or forceful. It is a patient, steady unfolding, echoing the gentle movement of thoughts as they drift calmly through the mind. Gravitational waves, first predicted by Einstein and observed by LIGO a century later, offer another layer of subtle beauty. These ripples in space-time, caused by cataclysmic events such as black hole mergers, reach us faint and quiet, carrying information about the most extreme corners of the universe. Let your awareness resonate with these waves, each thought a gentle vibration, each breath a soft oscillation in harmony with the distant cosmic symphony. Observations of the cosmic microwave background provide a map of the infant universe, a faint glow that speaks of creation moments after the Big Bang. Tiny fluctuations in temperature and density seeded galaxies, clusters, and the vast structure we observe today. As you rest, imagine this faint light as a soft, pervasive blanket, covering the cosmos and your own awareness alike, a reminder of origin, continuity, and calm order. General relativity also teaches us humility. Despite its elegance and predictive power, it is part of a larger story that includes quantum mechanics and the mysteries of dark matter and dark energy. Some questions remain unanswered: the ultimate nature of singularities, the unification of gravity with the quantum world, and the deep structure of space-time itself. Let your mind rest in these unanswered questions, embracing the calm of contemplation without needing resolution, allowing curiosity to drift softly like a leaf on a still pond. Science itself mirrors this calm approach. Observations, experiments, and mathematics unfold over decades, sometimes centuries. Discoveries accumulate patiently, each insight a quiet illumination in the vast darkness. Feel this patience reflected in your own body and mind, your breath moving slowly, each heartbeat a steady rhythm echoing the deliberate pace of understanding. Even everyday life is subtly influenced by general relativity. Time dilation, frame dragging, and precise orbital calculations ensure satellites function, communications remain accurate, and the technology we rely on behaves predictably. This quiet integration of theory into daily existence is a gentle reminder that the cosmos is not distant and abstract, but intimately connected to our lives. Sense this connection now, letting your awareness drift across scales, from your body to the sky above, to the distant galaxies that trace their silent paths across billions of years. The edge of knowledge remains wide, open to exploration. Quantum gravity, string theory, loop quantum gravity, and holographic principles all probe the interface between the known and unknown. Each approach is a soft step into the darkness, a careful tracing of possibilities. Allow your mind to rest in the calm of these possibilities, observing without strain, floating gently along the contours of thought, each breath a quiet voyage into the depths of understanding. The universe is a symphony, each object, wave, and particle playing its role in a grand composition. Planets orbit stars, stars illuminate galaxies, black holes bend light, and gravitational waves ripple across space. Energy flows, mass curves, and space-time itself stretches and ripples. Feel yourself as part of this symphony, your awareness moving in harmony with its rhythms, your body a quiet instrument reflecting the motions and energies of the cosmos. Time and space, energy and mass, matter and light, all are intertwined, coexisting within the framework of general relativity. Each breath mirrors the flow of space-time. Each heartbeat reflects the movement of mass and energy. Let your awareness settle on this interconnection, a gentle acknowledgement that you are both observer and participant, at once contained within and part of the vast, expanding and unfolding universe. Even in the face of unanswered questions and cosmic mysteries, there is serenity in understanding what we do know. General relativity provides a coherent framework, a map of motion, curvature, waves, and cosmic evolution. It reveals the unity of space and time, the interdependence of matter and energy, and the rhythmic pulse of the universe. Allow your mind to rest in this calm clarity, feeling each thought as a quiet ripple across the still waters of awareness. The universe continues its patient unfolding. Galaxies drift, stars burn and collapse, black holes merge, and space stretches outward. Observers on distant worlds may witness these same phenomena, their awareness tracing arcs and curves identical to ours. As you imagine this, let your own mind expand, feeling the gentle flow of time and motion, a soft mirror of the cosmic rhythms around you. Finally, contemplate the elegance of human understanding. From Einstein's thought experiments to modern cosmology, from precise measurements to gravitational wave observatories, each insight is a testament to curiosity, patience, and imagination. Feel your own awareness in this lineage, resting within the quiet pursuit of knowledge, carried along by the calm yet persistent currents of discovery. As you conclude this journey, allow the symphony of space-time to resonate within you. Breathe in the calm of understanding, exhale the acceptance of mystery, and feel the quiet beauty of a universe that is vast, structured, and intimately connected to you. You are part of this cosmic story, resting in harmony with its motions, reflections, and rhythms. The universe moves with grace, and so does your awareness. Gravity curves, light bends, waves ripple, and space-time stretches, yet everything unfolds patiently, deliberately, and quietly. Let yourself rest in this calm, a final meditation on the gentle, ordered, and infinite beauty of the cosmos.